graphs, again, we're starting by just loading in an actual model, and then we're going to play around with this. Uh, so, distribution systems support both. We have dedicated methods that return both a directed and an undirected graph. So you can do distribution system dot directed graph to get a directed graph, and for an undirected graph, you can call it get undirected graph, and that returns an undirected graph to you. Note, if you're calling a directed graph, if your system has loops, right? So for example, even if it has a switch that is open, what network X does is it randomly disconnects edges such that you have a radial network, right? So make sure you have a radial network before you call a directed graph. We are in the works of improving this logic. So for example, if you have a switch that is open, we're going to remove that automatically. But for the time being, what happens is that network X actually removes an edge automatically when you force a tree, right? And that might mean that there might be a component that you don't want removed gets removed, right? So just be wary of that fact.
What's the issue with just having graphs with cycles in them?
So we want to be, you can use cycles, right? But our use case in Cadet was we were using an optimization problem on top of this. We wanted a direct graph, right? Which is radial because we're using latest flow, for example, right? And for that we require we require a tree. We can't have cycles in them. So we are in the work. I mean, we have this is in the work. This is going to get modified a little bit, so you won't have to worry too much, and we'll have some warnings if there are things that are removed that that you might want to know what got removed. Essentially, we'll add these warnings here within the log. But for now, it's you need to be wary of this fact, if that makes sense. Just to give you an understanding, like when I called undirected graph on this, we had 88 edges. When I called directed graph on this, we have 85 edges, right? It turned it into a radial graph, and you don't know exactly what edges got removed, essentially, right? All right. So graphs in distribution from distribution system are extremely light, which means we don't add a lot of information inside them. So if you want to get information on what is connected to them, the way you would approach this would be using the get connected component function. So in this case, for example, we're passing what the bus name is and the type of component I want to figure out what distribution loads, for example, are connected to the system, right? And if I do this, it's going to show me that for this bus, this load is connected to the system, right? Does that make sense?
Can you use the type hierarchy here?
Sorry?
You can use the type hierarchy.
Yeah, you can, yes.